Okay, let's starting with the challenge problem of chapter 12. So the first one, if x equal is the 1 minus the I square root of 3, so you know for any complex number we can represent them in the coordinates of the xy, and for any of the complex number, it can be represented by a real, right? Here's a real, here the imaginary. It can by the represent by the real number. For example, it's a of the re. This is the a of the im, right? So any number of the a can be represented by the are plus the I of the AIM, or sometimes we also can use as a J or ARE plus J of the AIM. And also sometimes we can use the polar coordinates. So here is the R and here the angle of the theta, right? So you can see the ARE is equal to the R times the cosine theta, and the AIM is equal to the R times sine theta. So also the A can be represented by REJ of the theta. Okay, so the EJ theta is equal to the cosine theta plus j of the sine theta. Okay, so here if r equals 1, right, so it's a unit circle. Okay, now if we, by using this, let's see this. Okay, so let's see the mod of the n is 1 over 2 of the square plus the negative root 3 of 2 of the square, so it's 1. So now we know, okay, it's on the unit circle. So let's draw a diagram of this. So we know here is the half is positive, right? So it's positive and negative. So it's this. So you can see here is a 1/2, here's a 1 root negative 3 of 2. So here is the 60 degrees, right? So if this is the 60 degrees, okay, now let's see what is the, so we want to calculate the 1 over the x and x minus 1, right? Okay, so let's see what is x minus 1. Okay, so x minus 1 is equal to the negative 1/2 negative 2/3 of the I, right? So here is the real and imaginary. So you can see the other one is the 1/2, it's negative 1/2 is here, and this one. Okay, so by symmetry you can see this, so this negative 1/2, this is also 60 degrees, right? Okay, so now we know the two numbers. Okay, so x is equal to ej of the negative 60 degrees. Okay, then x minus 1, this is x minus 1, right? This is the x, so x minus 1 is equal to the ej of the negative of the 120 degrees. Okay, so this 120, so here is the 60, right? So this is the 120 degrees. Then the 1 over x times the 1 over x minus 1 is equal to the ej of the 60 degrees times the ej of the 120 degrees. So it's ej of the 180 degrees. When you go to the 180 degrees, that's here, right? So that's why it's negative 1. Next. So we want to write this one as a complex number, right? So as we see, I mean, if we can represent this one is equal to the of the r of the ej of the theta, right? So now then we know the square root of this, right? The root of this is equal to the root of this is equal to the root of the r times ej of the theta over 2. Okay, so now let's see, let's see it. Okay, so the r will be equal to the root of the 16 square plus the 30 square. That is equal to the 256 plus the 900 is equal to the 1156. Then is this one equal to the 2 times the 17 is the 34. Okay, so now we know the negative of the 16 plus 30i is equal to the 34 times ej of the theta. Now the theta is this, right? So this is the theta, and we know, let me redraw it. Give you okay, redraw it. Okay, so here is the real and imaginary. Okay, so we have the negative of the 16, and here is the 30, right? So this is the theta, right? So let's assume this is the alpha. Okay, so because that's mixed angle, so we can all use positive number, right? So this one is the 34 ej and the 180 minus the alpha. Okay, now let's see. So we have this is the 34. Now we know the cosine alpha is equal to the 16 over 34, and the sine of the alpha is 30 over 34, right? We can write this, and now let's do the square root, right? So the square root of the 34 of the ej 180 minus alpha is equal to the root 34 then ej of the 90 minus alpha over 2, right? So this one means that it is equal to negative 34. Cosine of this angle is the sine of the alpha over 2, right? Plus j sine, right? Of this one is cosine of the alpha over 2, okay? Now we want to calculating the cosine alpha over 2 from here, right? So we know the cosine alpha equal to 2 of the square of the alpha over 2 minus 1 is 16 over 34. So now we can get is the 2 cosine square alpha over 2 is equal to the it's the 50 over 34. Now let's do this is 25 over 34. Now we can get is the cosine, because alpha over 2, right? So alpha is a acute angle, alpha over 2 is also acute angle, so it's all positive, so it's 5 over root of the 34. Then the sine alpha over 2 is equal to the root 34, and it's to be the 3. Okay, now we can get into here, right? 34, then the sine is 3 over root 34 plus the I of the 5 over the root 34. So the answer is 3 plus the 5i. Or j, it doesn't matter. I, j is the same thing. Okay, so let w z be the complex number. We want to prove this, right? Okay, so let's w is equal to the wr plus the j of the wi, and the z equal to the zr plus j of the zi. Then we can see the w plus z of the congruent of the conjugate is equal to the wr plus zr, then plus the j of the wi plus the zi. So that means conjugate means flip the side, the imaginary part. Okay, for example, if I have this one is this is the ar plus the aim. Okay, so here is the theta, then is the conjugate means the imaginary part has been flipped. So this is the conjugate of the a is equal to the are minus the j of the aim. Okay, so here is the wr plus the zr and minus the j of the wi plus the zi. Okay, so and we can also use the w conjugate plus z conjugate is equal to wr minus j of wi, then plus the zr minus the j of the zi also equal to wr plus zr minus j of the wi plus the zi. So these two are the same, right? So that means that w plus z is equal to the w plus the z, okay, the conjugate. So now also you can prove this, okay, w times z is conjugate is equal to, okay, w conjugate times z conjugate. So if we use the polar coordinates to represent it, so here is the r and the theta, right? So here is rej of the theta. So conjugate means the sign go to the negative, right? So it becomes the rej of negative theta. Okay, so if we write the w is equal to the rwej of the theta w, and the z is equal to the rz of the ej of the theta z, right? So the w times z of the conjugate is rw times rz, right? And ej of the negative theta w plus the theta z, okay? And the w conjugate times z conjugate is rw e negative j of theta w, right? And rz e negative j of the theta z, so it's also the rw times rz and the e negative j of the theta w plus theta z, right? So that's why you see these two are equal. That's why we proved it. Okay, so this one we want to show this, right? Like we can do in the polar coordinates. So here you can see it's negative 1/2 and the root 3 over 2. So you know this is 60 degrees from here. This is 120 degrees. So negative half plus the root 3 over 2i is equal to the ej of the 120 degrees, right? So now let's see, this cube is equal to this cube is equal to ej 360 degrees is 1, right? So this is for the A. And for the B, we can see, let's draw this one, right? It's a negative 1/2 and negative of this, right? So you can see it's also a negative 120 degrees. So it's ej of the negative 120 degrees and with the power of 3, so of ej of the negative 360 degrees is also to 1. So we want to find a complex number that this one happens. Okay, let's expand in this. So the conjugate of the is a minus bi is equal to the a square minus b square, then plus the 2abi, right? So by comparing the complex number, we need a real equals 0, real, so a equals the a square minus the b square, and the negative b is equal to the 2ab. Okay, so now let's this is the 2, this is the 1. Let's see the derive the 2 a little bit. Okay, so we have the 2a plus 1 of the b equals 0. Okay, so now we have some two case. The case 1, let's see, is b equals 0, right? If b equals 0, a can equal to anything, then the first equation becomes the a minus the a square is equal to 0. This means that a of a minus 1 is equal to 0. So a equals 0 or a equal 1. So now we see the 0 and 0 and the 1 and 0 is a solution, right? And for the case 2 is b is not equal to 0, right? Now we need 2a plus 1 need to be 0. That means a equal negative 1/2. If a equal negative 1/2, then the b square equal to the 1 over quarter and the 1/2 plus the 1/2, so it's 3 over 2, 3 over 4, so b is plus minus negative 3 over 2. So now we know the other set is negative 1/2 and root 3 over 2, and the negative 1/2 and the negative root 3 over 2. Okay, so we find all of the sets. So next is this one is the same thing. Okay, we have the ax squared plus bx plus c equals 0, and in the before when we talk about quadratic, the a, b, c belong to the real number, right? And here the a, b, c belong to the is a complex number. Okay, so it's the same thing. Okay, no difference. So now let's see what is the delta is equal to the 18i of the square minus the 4 times negative 9 times 5. So it's negative 324. Then plus is 20 plus 180. Okay. That is negative 144, right? So now you can see that x is equal to the 2 times a is 10, then negative 18i plus minus the 12i. Okay, so that's why the x1 is equal to the 10 to the negative 6i, so it's equal to negative 5 over 3i. The x2 is equal to 10 to the negative 30i, so it's equal to the negative 3i. Okay. Okay, so the final one is what is the complex number whose square? So we need the m square is equal to the of the 90 degrees, right? So you can see the m square is 90 degrees, right? So the m is okay, we double the angle, right? So ej theta of the square is equal to ej 2 theta, right? Because it's unit. So here is if we know the 2 theta is 90 degrees, 2 theta is equal to 90 degrees, meaning theta is either equal to 45 degrees or theta can be negative 135 degrees, okay? Because this one from here is 90, from here is negative 270. It's the same thing, okay? So that's why the m can be equal to ej of the 45 degrees. So it's the root 2 over 2 plus root 2 over 2i, and the m2 is equal to the e of the negative j of the 135 degrees is root 2 over 2 minus the root 2 over 2 of the I. So that's the 2 m's. So yeah, that's it about for the challenge problem of this chapter. Thank you. Bye bye.